The law of sines can be used to solve SSA triangles, where I'm given two sides and the opposite angle from the first side. The problem is that depending on the length of that first side, the side that's opposite from the angle, I can end up with different possibilities for the resulting triangles. So I need more information than just the lengths of the sides in order to determine which particular case I'm looking at. So let's take a look at how this works through this diagram. In one case, I have the first side, the side opposite from the angle, that's shorter than the altitude of the triangle. In other words, the height h is actually longer than the side that I'm given here, and look what happens. I cannot make a triangle from this because this length does not even reach the base to complete the triangle, no matter where I position it. So if I'm given a side, and an angle, I'm going to have to check first to see if this side is even long enough to make a triangle. In this case, it's not. In the next case, I have the situation where this first side that's given is exactly the same length as the height. And in that case, there's only one place where it reaches the base, and that's along the height. And so when the first side that's given is equal to the length of the height, I end up with a right triangle. So that would be this case here. In the third case, I have the first side that's given in the green is longer than the height, but it's also shorter than the other side, the second side that I'm given. So you notice that it's longer than the height, shorter than this side. Okay, so the length of the first side, S, that I'm given is in between the length of the height and the second side. So what does this do? Well, this is actually what is called the ambiguous case. And the reason it's ambiguous or unsure, uncertain, is because I could make a triangle like this, okay, like this triangle here, or I could make a triangle like this. Okay, so when the length of the first side, the side that's opposite from the angle, is between the length of the height and the length of this side, I have the ambiguous case, which means I'm going to have more information to determine which of these two triangles that I'm creating. And the last possibility is that the first side that I'm given, the side in green, is longer than both the height and the second side. And in that case, the only place that this side can meet the base is with one triangle like this. So since in each of these cases I have to compare the length of the first side to the altitude h, obviously it's going to be important to know how to calculate the value of h. And so that's what I've done right here. Since h forms a right triangle with an angle opposite from the side h of a and a hypotenuse of s1, the equation for the value of h is s1 times the sine of a. So given the information of a side, which would be out here somewhere, okay, the green side that I was showing you, another side, this red side, and an angle, I have enough information to calculate the value of h that's going to allow me to determine whether the green side, the other side that's given, is going to be enough to make a triangle at all, whether it makes one triangle or whether it makes two triangles. So to determine which of the possible cases you're dealing with here, this is the process that you're going to follow. First, you have to find the height of the triangle, which is going to be h equals s1, the second of the two sides that you're given, times the sine of the angle that you're given, s1 times sine of a. Once you have that number, now you have to compare the length of the side s that you're given, the first side that's opposite from the angle A, and test that against the value of h and against the value of s1 to see which of the cases you have. If the first side s is shorter than the height of the triangle, then no triangle is possible. If s is equal to the height, then you have a right triangle. If h is less than s and s is less than s1, in other words, if s is between the length of the height and the length of s1, this is the ambiguous case, and you have a possibility of two different triangles. And finally, if s, the first side opposite from the angle A, is greater than the second side s1, then you have only one triangle, which is not a right triangle.